Okay, I was well on my way to obtaining the PhD in chemistry at UCLA. I already obtained a master's degree in chemistry from UC Irvine. My interest is in medicine. I had all my life had the hopes of doing something like, you know, the guy that discovered penicillin, and revolutionized medicine. Penicillin became the basis for big pharma. That's where they got their start. Excuse me. And I've always loved people, and I was not ever really worried about having money. I just felt like that's something I never would have to worry about. I needed a purpose in my life that involved doing something, and I wanted to learn everything I could about medicine so that I could help people. And of course, being young, I was still also very interested in drugs. I had not really lost interest in even cocaine. Had not done very much. I was still a bit curious about it. I dream of a day when I could make my own and learn more about it. I've since totally lost interest in it. That's another story. But the psychedelics I was interested in, and that's another story. But with my interest being in medicine, I was a synthetic chemist working towards a career in the pharmaceutical industry research department where I would research new drugs. I was developing new methodology. I would have been like at the top of pharmaceutical research because I would be developing methodology. I was developing new methodology for chromium carbene chemistry. At some point, I discovered a whole new compound that had never been made and a whole new technique that had never been discovered. It was a passion for me to study chemistry. But there are certain hurdles to getting a PhD, and one of them where I was I had to write a research proposal for something unrelated to the work that I was doing. And since HIV was the big thing, it wasn't long before I stopped watching television, but at this point I would go home every day in time to catch the news, and HIV was at the front of all the news. First thing they covered, there was a big scare on about HIV, becoming a real monster. So, I had the keys to the library, and it was just right down the hall. And typically I would start a reaction and then I'd have a lot of free time on my hands and I would go and live in the library. I burnt the midnight oil many times. I mean, I had been down to Hollywood enough. I didn't care to go down there. I knew that there was nothing really good there. It was all just decadent. Some people think that that's the spice of life. Well, so be it. I was interested in medicine and chemistry, and I was studying HIV at this point. I wanted to know everything I could find out about it with the hope of writing a proposal with regard to something that might help fix the problem. I would start with a journal article. Every journal makes a lot of, I mean, every uh, article published in the scientific journal, they make a lot of statements, and almost every time something is said that can be referenced to another paper or other papers, that's all in the footnotes. There's a lot of references. So I would take a book off the shelf in UCLA Library, the Physical Sciences Library. They've got a very large collection of the scientific literature. So I didn't have to do much on the computer. I had it all right there, hard copies. So I would read Journal of Organic Chemistry, Journal of American Chemical Society, Pharmaceutical Science, National Proceedings of National Academy of Sciences. I actually have a subscription to about 20 of these journals that were coming in almost every day, and I was, surveying the literature of the day, but then I had access to all the literature of the past. And I would take down a book and start reading an article, and I would, as I went through the article, I would go and grab every reference that seemed possibly interesting. And I would sit there and I'd have books laid open on top of books laid open, stacked, 10, 12 books. And I'd read this one, close it, and read the next one. I'd take some notes, but mostly I was just reading, trying to. And finally, I put the whole picture together of what could be known about the virus itself and all the different approaches that were being taken to eliminate the problem. Most of them, if not all of them, were really focused on certain mechanisms of the virus. So the virus is sort of like it's like a ball that attaches to certain sugars on the human immune cells, certain cells in the immune system. And once they're attached, they would be like stuck like, glue, and then they would open up and open a hole in the cell and deposit information. And then the information would, the key enzyme for HIV is reverse transcriptase. That begins all the HIV. And what reverse transcriptase does is it inserts information into the DNA of the cell that it enters. So when that cell reproduces and it reads that DNA, it now produces the information that the reverse transcriptase added into it. Reverse transcriptase is not an enzyme that was manufactured in the laboratory. It was discovered in Vishnu virus in sheep in the 40s or the 50s. Vishnu virus is a disease that causes sheep to walk around in circles and they go crazy and die. And they discovered reverse transcriptase. Very interesting enzyme because it added information to DNA. And as I know now, as I've learned through HIV and then COVID and then the vaccine, reverse transcriptase is in the HIV virus and it's in the vaccines that they manufacture. So anyway, there was that, and then I kept reading a lot of stuff, and then I discovered that there were some people, Rockefeller University in New York, they published in the Proceedings of the National Academy of Sciences 2 articles back to back, 1987, 1988, pretty sure that's right, about research that they had done with hypericin. Hypericin is a very interesting molecule that is found in St. John's wort, which is the oldest medicinal herbal medicine in the Western inventory of herbal medicines, whatever. It was used for almost anything, for everything. Hypericin was once put on the market by Big Pharma as an antidepressant. And it's a very interesting drug to study in that respect. So I began working towards a retrosynthetic technique of making hypericin. And I came up with a proposal, and it was 27 pages long. I asked my professor how long does it need to be, and he pulled up some of his old proposals, and he said, I don't know, I think it can be up about 30 pages. And everyone that I gave it to, all the professors, they said, this is very good. I even had a couple of them say, this is the best proposal I've ever read. Good luck with it. It involved a couple of techniques that had never been reported, such as the technique that I was working on in my lab and the technique of a friend that was still being developed at University of California, Santa Barbara, had not been published. So no one else could have come up with this synthesis. And it was a synthesis that involved 10 steps. And the rule of thumb is, if something is going to be commercially viable, it's got to be made in 10 steps or less. They still had not, at that point, been able to synthesize from scratch morphine in 10 steps or less. That's why they're basically harvested from opium, from the poppy plant. So anyway, to me, this is very fascinating, and I submitted it to to the NIH, National Institutes of Health. And later I found out that okay, there's two things you got to do if you're going to do research in a laboratory, if you're going to be a chemist. You got to publish papers, publish affairs, and you got to get funding. So that's why I was made to write a proposal. That's how you get funding. You submit it, and then they say, yeah, this is good, we'll fund it. They sent it back to me and they said, we have a 7-page limit. It was 27 pages long. So they didn't even read it. And I'm thinking, they were talking about the cure for AIDS, and they're not even going to comment other than that it's too long. Reminds me of the guy, Mozart's rival telling the king said, what's wrong with Mozart's music? He says, too many notes. Same thing. So anyway, I kept studying, researching. I began to take an interest in psychedelics, but I was still trying to solve this HIV thing. And I read so much literature that I began to piece together this idea that they had discovered that synthetic antibiotics, like I said, penicillin is where it all started, and that's an antibiotic. And then they began to synthesize analogs of penicillin, things that looked like it but were different and so forth and so on. And that's where Big Pharma got its start. Synthetic antibiotics, that was the basis for their fortune. And of course they made a lot of synthetic antibiotics that had a lot of side effects. They were actually quite harmful. And then they came up with better ones, so the harmful ones were they could no longer be sold in the United States. But what Big Pharma, now when I say Big Pharma, I'm pointing a finger at Fauci because he is like at the top of that ladder. He can make it to where someone gets funded or not get funded. I mean, I've heard this from a lot of other people, and where Fauci actually got his rise was with HIV. I've heard some stories about how so-and-so discovered it, and Fauci took the credit away from him. It's bizarre politics that were involved there. So I realized he's a really brutal player in the financial aspect of Big Pharma. So what I found out was that people were beginning to discover that the synthetic antibiotics that were no longer legal in the country were dumped on third world countries like in Africa. By dumped, I mean given to them for free, and here's free medicine. And they knew about all the side effects and everything, but they didn't realize what was going to happen when they dumped them on third world countries like Africa, where the men generally have many sexual partners, and maybe they did know, maybe they didn't. But anyway, HIV, it turns out, was easily spread through a certain kind of sexual contact, and a lot of people began to have immune system failure. The immune system failure that was happening, now this is before HIV. There's a rash of it happening because of people taking synthetic antibiotics because they have many sexual partners, and the load on the immune system is heavy, and it causes them to have problems, and so they give them these synthetic antibiotics, and then they realized that the immune systems were failing catastrophically. They were failing altogether, so the antibiotics were not just sort of helping them, it was actually destroying them. So they needed something to take the blame. Big Pharma did not want to be left holding the ticket for all these poor black males who were dying from compromised immune systems because of the antibiotics that they were taking. So they needed something to put the blame on, and I know Fauci had to be like the guy. I mean, I began to, okay, here's another part of the picture. I'm in LA, and I'm drawing attention to myself because of the things I'm saying, and I'm outspoken. And all of a sudden one day I'm walking through Westwood, through a very nice little strip mall, and there's a guy got a office set up. There's basically a store for rent, but there's no store there. He just sort of paid the rent for a month to sit in there and tell people the truth about HIV. He had posters, and I went in there, and he spent about an hour explaining to me how the HIV epidemic began in hepatitis B vaccination trials that were given in Los Angeles and Boston and several other places. And he was so believable that I had to look into that as well, and I found out it's actually pretty easily proven. Okay, so all of this is starting to come together for me, and then it all crystallized when I read this paper in a statistical biochemistry type of publication. It was some obscure genre that almost no one read because it was highly specialized. But it was someone who did a statistical analysis of the HIV virus and compared it to SIV. They were saying that it came from a monkey, simian immunodeficiency virus. And by the known mutation rate and the statistics and that sort of thing, this author proved that it was not possible that HIV could have been the result of mutation of SIV. No matter, even if humans and monkeys share blood, it's just not possible. However, and this was the kicker, this is what crystallized the whole picture for me. He said that it could be shown that, statistically speaking, HIV could have come from BIV. It was actually much closer to BIV than it was to SIV. BIV is bovine immunodeficiency virus. It's a virus that a lot of cows have. It just goes up in their test, but it doesn't really cause any problems. It's just a resident virus. But anyway, through gain of function, that sort of thing, bing, came together to me that HIV, first of all, HIV wasn't at all as harmful as they were making it out to be. It just happened to be present in a lot of people that had immune dysfunction, but not all of them. And many people that got it didn't have problems. But anyway, so it just all of a sudden made perfect sense to me that if you take BIV and aggressively cultivate it in the presence of virus, because they're both RNA viruses, which means they have high mutation rate, they produce a lot of mutant daughters, so to speak, and the mutants will survive and live if they find a suitable environment. And so, with the millions and billions of mutants, if you aggressively cultivate them, I mean, you get a wide statistical distribution, big population. And so if you aggressively cultivate them in the presence of human immune cells and keep fishing out human immune cells to find one that's infected with something unusual, then clone that daughter virus, which has components from BIV and components from virus, but like to live in human immune cells. All you got to do is clone it, and now you've got something that you can inject into a person. It'll be attracted to the human immune cells that are set up shop there. And so it all came together. That's something that was introduced to the population during these vaccination trials so that it would show up in their blood, and so all of a sudden they discovered it. Now, it's not an exotic stretch of the imagination for me to see Fauci sitting at one of these tables with 2 or 3 people trying to figure out what to do, and they say, well, we've got this virus that we manufactured from cows and sheep. That's the kind of research they would have been doing anyway, because if you're looking for something that won't generate an immune response, since we eat cows and sheep, those are good sources of virus is, a virus is not necessarily something to make people sick. Because I could see that when you look at the full details of HIV, it's actually like a messenger. All it does is deliver, like a postman delivers a letter. It delivers reverse transcriptase, which is the main thing, and then whatever RNA is also present in that cell, it would insert that RNA, messenger RNA, into the DNA of the host cell. So, in my opinion, they manufactured this virus that would target and live in, and I think when they first made it, they were looking for something innocuous, that wouldn't hurt anybody. They had other plans for it, such as deliver information to the immune cell to make it better and stronger. But now, anyway, they needed a scapegoat to blame this HIV on, and they had this innocuous little virus that they had manufactured. Somebody suggested it to Fauci, and he said, okay, that's it. That's what we're going to do. We're going to put that in the population, and then we're going to discover it, and we're going to blame this whole epidemic of failed immune system on that virus. Now, I've got tons of information to back up everything I've said here. Nobody else is saying it. This is my theory. I put it together. But I can totally support every component of this idea, this theory. Don't worry, there's that.